Hello students, we start the part 2 of chapter Indices, which is plural of index. Index means power. These are all index or exponent. Plural of index is indices. So in my part 1 of the video, I gave you the concepts, lot of concepts. So here just few, because we are going to do questions which are neither very easy nor very difficult. We are going to do from ML AGGARWAL exercise 8, 11 onwards. Part 1 I did with 1 to 10. So if you want to see introductory concept and easier question, please see my part 1, then you can see this part 2 video. So first one, just let me recapitulate what we have done so far. Product law: when bases are equal, powers are added. Quotient law: when the bases are same and when they are divided, powers are subtracted. Last one is called power law. Power's power is multiplied. And there were many other small things which I have shown you in the part 1 of my video lesson. So here we move on to question number 12, part 2. So as you see here, we have 5 to the power n. If you see nicely, this should be our idea to take out 5 to the power n common. So what I do, this I write as just the opposite of product law. Just opposite I do. Product law tells you this, and to this if it is, you get this. So simply I take the converse of product law. So 5 to the power. So what I am doing, I am writing your 5 to the power n ahead. So I have taken out 5 to the power n. Here also, if you see 5 to the power 3, if you multiply, you will get back this. This is 6. 5 to the power n I have taken out, and this is 5 to the power 1. So as I told you, this is the reverse of product law. So 5 to the power I take out, I am left with 5 cube. If you take out this, you are left with 6 into 5. If I take out 5 to the power n, I am left with 9 here. This comes out. This comes out 4. So if you see, we can cancel 5 to the power n. So what we are left with, children, is 125 minus 30 by 9 minus 4 is 5. So ultimately we get 95. 125 minus 30 by 5. If you cancel, you get 19. So kindly pause the video and go back and copy the sum. Now we move on to question 15, part 2. So what I'll do here, children, I will open the bracket here, and here if you see, first I will write this as power of 5. So I use this power law here. You will see next step, power's power will be multiplied. So 25 is 5 square and 125 is 5 cube. So ultimately what we get, children, this already I have multiplied. Here if you see, this will be 5 minus 14, 2 2s are plus 4x upon 5 to the power 6x. So here finally we get into the powers are added 2x plus 12 minus 14 plus 4x, and this quotient will be subtracted. So if you see total, what I get is 5 to the power 6x minus 6x. 2x plus 4x is 6x minus 6x, and minus 14 plus 12 is minus 2. So this cancels. Ultimately we get 5 to the power minus 2, which is 1 by 25. So if you see here, 6x minus 6x minus 14 plus 12 is minus 2. 6x plus minus cancels. 5 to the power minus 2. In my part 1 I told you when minus 2 goes, you can write it becomes plus 2 in denominator, and minus becomes plus 2 in denominator, denominator minus become plus in numerator, and 5 square is 1 by 25. So kindly pause the video, copy and practice. Now we move on to question 17, part 2. So there is one algebraic identity a minus b a square into a square plus ab plus b square is this. So see this here, only difference is here, children, a is x to the power 1 by minus 3 and b is x to the power 1 by 3. So same format. This will look little difficult for you. Many children, they ask me to explain it again. So remember, this is in this format. X is this, A is this, and B is this. So actually this is nothing but a cube minus b cube. This is the expanded form. A minus b, a square. This is ab, because this two if you multiply, it will cancel and give you 1. If you want to see here, I'll show you x 1 by 3 into x minus 1 by 3. So minus becomes plus down and this cancels. And this is also b square. So this is nothing, children, but cube of this minus cube of this. So when you open the bracket, this 3 will cancel and this will also cancel. You will get x to the power 1 minus x to the power minus 1, and this will go down and become positive, and this is your answer. So once more, this is nothing but expanded form of a cube minus b cube, where this is a and this is b. So we cube both, we get this minus 1, it goes down and become plus 1. So please copy and practice. So next we move on to question 19 part 2. So this first step we can write a minus b in the bracket because of quotient rule, and similarly this will be x b minus c. This bracket will put in the next step, and this is x c minus a. Now if you remember, we have power law. Power's power is multiplied. So if you remember, you can note that a minus b a square plus ab plus b square is nothing but a cube minus b cube. You can see my first question very similar. We had, if minus is here, this will be minus. Next question you will see in part 3, this will be plus, same way you will do, children, but it will be a cube plus b cube. So this becomes a cube minus b cube. This becomes b cube minus c cube, and this becomes c cube minus a cube. So when bases are equal, we add the power. So when you add the power, a cube, b cube, b cube, all are in pair, plus minus. So you'll get x to the power 0. So anything to the power 0 is 1. So what you will get? X to the power 0. So when you multiply all, answer will be 1. So we had to find the value of this. So once more, here we have used a cube minus b cube formula, and we got this is a cube minus b cube, this becomes b cube minus c cube, and this is nothing but c cube minus a cube when bases are same. When the bases are same, so here we have the same base, then the powers are added, and anything to the power 0 is 1. So please copy. So we go to next question, that is question 20 part 1. So we see here, this is we can write as 1 by a plus 1 by b divided by 1 by a square minus 1 by b square. So if you take LCM, children, it will be AB, B plus A will go B times, B will go A times, and this is division, remember, not minus. So if you take LCM, so it will be A into B square, A square will go B square time, minus B square will go A square time. So we have b plus a, ab, when division becomes multiplication, denominator becomes numerator and numerator becomes denominator. But here one more thing I am doing, not only I am making the numerator into denominator, I am expanding it with difference of square, b square minus a square, b plus a and b minus. So lot of cancellation will be there, children. A will go with a, 2a, 1a will remain, 1b will remain, and this cancels. So we have ab by b minus. Any doubt you have here, you could have written this as ab into ab, a square b square. So one pair will cancel. So anyway you do, AB will remain in numerator and denominator will be B minus A. So children, question up to 1 to 20 was simplify. Question 21 onwards. So pause the video and copy this. Then I am going to show you 21 onward how we are going to prove. So see 21 after copying this. So 21, if you see, we have to prove. So we will start with one of the side and we will prove the left hand side generally to be equal to the right hand side. So children, question 21 is prove. I start with LHS. So LHS is a plus b to the power minus 1 into a to the power minus 1, b to the power minus 1. So we know that rule, if you remember, anything negative power becomes positive in the denominator. So this goes in the denominator and becomes positive. Similarly, this 2 comes to this form. So we have 1 by a plus b, and when you take LCM, it is AB. A will go b times, b will go a times. So ultimately, if you see, children, what happens here, I can show you in this step only. This 2 will cancel and you will get 1 by AB, which is nothing but my right hand side. This is to the right hand side of equal to, this was to the left hand side of the equal to. So prove the following question, you will follow this format. So I have proved left hand side is equal to right hand side. Kindly pause the video and copy. So we go on to the 2 more sums, and they are very interesting. They look hard, but if you practice, it will become easier. So we have got A is c to the power z, B is a to the power x, and C is a to the power b to the power y. So we have to prove x, y, z is 1. So see how we start. What we do, we take first one, and in the first we substitute the value of c from 3 in 1. So we substitute value of c from 3 in equation 1. See what happens. C is by, c is by. So simply I have substituted in place of c by. Similarly, now b's value, here we write a to the power x. Before I do that, one small thing I'll do. See, power law. Power's power I multiply. Then next what we do, so this side is my a. So here in place of b, from equation 2 we get b is a to the power x. B is a to the power x. So from equation 2 we substitute b equal to a to the power x. So we are working on equation 1 only. Now you see, this is nothing but a to the power 1, and by power law, you know, power's power is multiplied. So it becomes a to the power x, y, z. So when bases are equal, then powers are equal. So see here, bases are equal, so x, y, z, therefore you can write is 1. This is what I had to prove. So one small thing you can write, since when bases are, you can write in small letter, I'm writing in capital letter to make it more prominent. When bases are equal, then powers are equal. And sometimes, children, just the reverse happen. When powers are equal, then bases are equal. You may see in the other sum. So kindly pause the video and copy, and then we will move on to the last sum, 24. So today's session I am going to the last question, 24. So here this question was given here. If this is given, you have to prove this. So what we have, let this is equal to this is equal to this be equal to k. This k method is very important in class 10. For class 10 also you will see, this is class 9. So for solving ratio, so ratio sum, we have lot of application of this. So how we go about it? See, one very important thing I'll teach you. If 2 to the power x is k, see 2, if this power is transferred to the other side, this you can take it as a rule, is becomes k to the power 1 by x. Same way, if 3 to the power y is k, 3 is k to the power 1 by y. So when 2 alone here, x goes there becomes 1 by x, y goes there becomes 1 by y. Same way, 6 to the power minus z is k, therefore 6 is k to the power minus 1 by z. These things are very important if you want to do this sum. So remember this, 2 is k to the power 1 by x, 3 is k to the power 1 by y, and 6 is k to the power 1 by z. Now we know, you can see one solved example in the book, I think question solved number 8, very similar, very nice question. So we know 2 into 3 is 6. This is how we do, children. You will say, sir, we got it. So through practice, through experience, you will learn. What is 2, children? K to the power 1 by x. What is 3, children? K to the power 1 by y. What is 6? 6 is k to the power minus 1 by z. So finally, when bases are equal, I am not writing, I wrote here, powers are, so before I do powers are equal, first I will use the first rule, product law. Bases are same, powers are added. Now I move on to the, what I wrote here, when bases are equal, powers are also equal. So 1 by x plus 1 by y is equal to minus 1 by z. So finally what you do when you bring, so once more, when bases are equal, powers are equal. I'm not writing, you just see previous question 22 I wrote, same reason you will write here, since same thing, when bases are equal, then powers are also equal. So last part, bring this to this side. 1 by x plus 1 by y plus 1 by z is 0. So 1 equal to is there, you put implies sign here. So this is what we had to prove. So you write hence proved. So kindly pause the video, go back and try to do all sum up to 25, 26. You can do solved example also, and in the part 3 we will see the most difficult question of this exercise. Thank you boys for watching.